Today we are inviting Dr. Kristina Boerder, who is a postdoctoral researcher at Dalhousie University, working with Dr. Derek Dickinson on the interaction of global fisheries and marine conservation measure, as well as the role of climate change. She is originally from Germany, and she moved to Canada in 2013 to conduct a PhD at Dalhousie University, Halifax, in collaboration with Global Fishing Watch. Our project focused on the use of satellite-based fishing vessel tracking data for marine conservation, the role of transshipment of catch and seafood supply chains, as well as the conservation of biodiversity in area beyond national jurisdiction. She completed her PhD in 2018, and since she has been working with academia, industry, and NGO on the use of big data in the context of marine spatial management. And Kristina, it's your turn.
Thank you very much. I could listen to you all day saying Halifax with your nice French accent. Yes, thank you so much for the invitation. It's exciting to be presenting remotely and be talking about protecting marine biodiversity in the Anthropocene, and use that rather broad title to talk about some exciting new research and new data products that have appeared over the last couple of years, and also present some ongoing and future work. And I'm very much looking forward to hearing your thoughts and the discussion afterwards. So I'm really preaching to the choir because there's a lot of amazing research and knowledge coming out of UBC on that end. But I would like to start very broadly with some thoughts on the Anthropocene as the age of change, and the age especially of rapid change, illustrated here with different fishing techniques over the centuries, starting in the 1500s or 1520s, very manual labor intense and yeah, of course, very different styles. I don't know what the pike in the middle of the fish in the right of the picture is doing, but I'm pretty sure it had its reason. Two more boat-based fisheries, all under sail and manpower in the 1820s. In this case, the depiction is with dip nets fishing for tuna. And I'd also like you to know what the fancy ladies in the background watching the fisheries. To the 1920s, where still a lot of the fishing really happened from bigger schooners under sail. And as a little trivia bit here, if this boat somewhat looks familiar, you may have another look at your 10-cent coins, the Canadians at least. This is the Nova Scotian Blue Nose, at that point the fastest sailing schooner that won several noted races, and a rebuild can still be seen in Nova Scotia sailing up and down. Highly recommend when travel is possible again. To, of course, the 2020s, now we have the industrialized fishing, which really is quite decoupled from this history, with high-tech equipment, fish finders making use of helicopters, satellites, and of course, under enough power to go as long as and as far as needed. And that really is illustrated by this work by Rousseau et al. From 2019, who looked at the rapid fleet developments and found that the global fishing fleets roughly doubled between 1950 and 2015, as you can see in panel A. And most of these actually by 2015 have been motorized, not quite 70%, which still leaves quite a significant amount of vessels that are not under power. But you can see how quickly the uptake of motorization of different power amounts have been going in panel C and further on between industrial and artisanal fleets. And this is probably a graph that all of you have seen once or twice at least. So this motorization really has enabled the vessels to go further, to fish longer, and to access fishing grounds that were not as easily accessible before. However, after quite a noticeable increase of catches, since about the 1990s, catches are stagnating. This is the orange curve shown here, or the yellowish curve shown. So despite fishing further, fishing in new places and fishing harder, not more, the vessels are not catching more. So this, of course, comes on the background of increasing overfishing. And no matter how you name it, about a bit more than 1/3 of the fish stocks are unsustainably fished and classified as overfished, whereas about 60% are maximally sustainably fished, and a steadily decreasing amount can be classified as underfished, which is just above 6% currently. So on this scenario, of course, spatial protection measures are coming into this discussion and have been more and more a broad feature of the discussion around management, sustainability, and conservation, of course. And this screen grab was taken from the latest World Database on Protected Areas, and shows that we on land have currently about 15% protected, and for the oceans we are around 7.6%. That number, of course, is open to a certain amount of debate regarding what one considers protection, but regardless, most of it is focused on the exclusive economic zones of countries and the high seas, the global here, areas beyond national jurisdiction, ABNJ, are massively underrepresented. This has been a fairly recent trend, as you can see here over time. So as especially denoted by the light blue curve and to a certain degree by the darker blue one, the marine protection really has been pushed forward about the last two decades. So this is a good development, definitely. But if we look at how biodiversity is doing, and this is a more overall trend, of course, including terrestrial, despite more protected areas, we continue to lose biodiversity at rapid rates. And here you can see some of the rates are really concerning as presented by continent. And right now, these features is the conservation as we've been doing it and seeing it has been largely reactive and aimed at really slowing down this decline. So focused at losing less. And I find on this background, this comic or cartoon really hits home, especially regarding now. So we are facing oncoming waves, and we are right in the middle of the COVID wave, of course, but there's more coming, and climate change and biodiversity collapse are really the looming waves on the horizon. And so I think we really need to be thinking about how we're going to face these waves and with what attitude, which hopefully goes beyond hand washing and all will be well. So I'd like to spend a short time on talking about how we approach this kind of science before jumping into some novel and ongoing science. And I really like this publication by McDonald et al. From 2019. With thoughts on different types of approaches for science and fisheries management, from inactive approaches to very reactive management and science to the proactive approaches, and realizing that this might be a bit small on your screens. I would like to highlight the proactive approach they have phrased here, which is really scientists actively participating in decision-making and actively targeting studies to provide data and knowledge that can be applied. And really supporting the anticipatory option so that actions can be taken to mitigate any negative impacts, or even, as they say here, capitalize on change in a wise way. So really what I want to stress here is to move from a reaction to a proactive, wise response. Knowledge is key. And there's been a lot of good knowledge looking ahead regarding what is to come for the aspect of climate change. And that would definitely be too much to be talking about all of this. So just an example from the FishMIP project, the Fisheries and Marine Ecosystem Model Intercomparison project. Here taken from Lotze et al. 2019, presenting two different scenarios for two different climate change scenarios, so 2.6 and 8.5. The spatial patterns of projected biomass change. So this is 2090 to 2099 relative to 1990 to 1999, and does not consider fishing. But especially if you look at the upper row, panels A and B, you can see that the biomass change is obvious for both scenarios. and will mostly impact, of course, the equatorial and temperate areas, whereas an increase of biomass is expected for the poles. And if you take this a step further, as was recently published last year by Brendan Buchholz et al., to really look at what does this mean for example, fish catch. So this is a study looking at changes of fish catch for the 2030s and 2090s for the NAFO area, so North Atlantic here around Atlantic Canada and Greenland. You can see that a lot of different areas are expected to have declining catches, especially focusing on the traditional areas here around the Grand Banks, which is the dark red in the 2090s area. So, and of course, developing fishing grounds for the Arctic and high Arctic, which is currently under protection, but this needs to be considered if we talk about further protection for the Arctic areas. And this, of course, directly correlates to species being on the move. So this is just a rough example of some terrestrial and marine species that have been found to shift and have either moved further north or further down for marine areas or further up into cooler climates for terrestrial. And knowing this, we need to figure this in because we need to start planning for change if we want to move from the reactionary approach to a wisely responsive approach. And we've been had a very interesting workshop a couple of years ago with some people also from UBC present, and really discussed how this can be approached for marine conservation. And in the upper map here, you can see the colors representing historical sea surface temperature variability and time of sea surface temperature emergence diverging from pre-industrial levels. So the colors correspond to the lower graph. And you can see that there's a fairly good spread regarding when sea surface temperature is expected to diverge. But also, and that is referring to the lower panel, the locations of marine protected areas across the spread. So this is depicted by the dots in the box itself, but also represented by the histogram on the outside. And as you can see, especially regarding historic sea surface temperature variability of the areas, we've got a pretty big skewed data regarding, or not skewed data, skewed locations of marine protected areas regarding historical variability. So this can have direct implications, of course, how stable and or how vulnerable ecosystems might be regarding changes of temperatures to come. So knowing these kind of things really helps us to implement climate change adaptation and biodiversity conservation in marine management, and especially include climate change adaptation principles into not only the MPA siting, which is addressed here, but also the design, the management, and of course the objectives. And we're really at the start of this. We've done a quick overview or a survey of how many protected areas really incorporate climate change into their management plan. And we've come up with only a handful of examples. So this is really at the start right now. Then also to build climate change into post-2020 targets with the period we've just started, and having participated in a couple of international meetings, I was personally fairly disappointed how little climate change really is taken into account. So it's the elephant in the room that no one really wants to talk about because it's so hard to address, and there's no good guidelines on how to do this. So we really need to work to develop the tools and the designs for dynamic and responsive management. And coming out of that same publication, we're making a couple of recommendations how this can be done, of course, also considering policy and legal anchors, and suggest a couple of ideas how, for example, dynamic management can be used to supplement and expand the current static marine protected area feature, because as you can see in the upper lines, the current network, of course, has its targets and covers these targets to a certain percentage as shown in the bar graph. But if some of these species or ecosystems move, these targets will fall short. So We have a suggestion on dynamic ocean management areas that might be used to expand this network. So similarly has already been done, for example, here on the Canadian East Coast with the North Atlantic right whale closures. So this would be more seasonal, to what we call climate responsive biodiversity closures, which would be a hybrid between a seasonal and an MPA that can be put in place for certain amounts of time until objectives are being reevaluated and remeasured, for example, to track ecosystems on the move or species on the move. So if you're interested in that, this is the current focus of the work of our lab here at Dalhousie. So I'd like to switch gear a bit from looking into the future to looking at the human impacts we have right now, which is like right in front of our noses, and talk a bit about the marine data revolution, as I'd like to call it, that the AIS data has brought. So in the background, you see a map of global fishing effort for the year 2016, which we published in 2018. And this is an effort for a whole year covering about 55% of the global ocean. And it comes from a tracking device called AIS, which stands for Automatic Identification System. It's a transponder on a vessel that sends information about the vessel, such as type of vessel, position, speed over ground, course, and a variety of other information, mainly to other vessels in the first line, because it's a tool for navigational safety. But these signals can also be picked up by satellites or towers. And we can use this kind of information, similarly to tagging animals, to follow their tracks and really see what the vessels are doing. And just to give you an example what this looks like and how we can use these tracks to not only classify what type of vessels, or in this case, what type of fishing vessel with what type of fishing gear it is, but also its activity. Activity mostly, of course, traveling versus fishing. And you can see here for the first panel, the trawlers have these long swooping patterns when they drag a net through the water column or across the seafloor. And compared to longliners that set a line usually at fairly high speeds, the line can be up to 100 kilometers long and then retrieve it. So these back and forth patterns develop. Compared to purse seiners who set a net around schooling fish, such as mackerel, for example, or smaller tuna, where these looping patterns develop and then the vessel stays attached to the net to scoop out the fish. So by training a neural net to automatically classify these patterns, we can now detect fishing effort and classify it as seen from the AIS data. Before I dive into some of these studies and data sets, I would like to highlight some limitations of using AIS, because I think this is important for the wider understanding what is possible with it. And firstly, it is very important to know that not all vessels carry AIS. So this is different to the often government mandated VMS, the vessel monitoring system, which is a closed system that governments usually use. It's very hard to access this data, with exception of some countries who have chosen in the name of transparency to share it. And we don't really know the exact amount of vessels that carry AIS, because the exact amount of vessels itself is unknown. So we have a rough estimate, which of course varies by size class. Not so much a problem anymore is the incomplete satellite coverage, which has caused some gaps in the data in the past, but is continuously improving. So that is a very good development. But then also something that is of importance to know is that AIS actually can and is tampered with. So the device itself, they can be switched off, or the location or the identity can be spoofed, so falsified. And an example is shown right here. So the track we got from the AIS data was the red one, which looked rather suspicious. So with a bit of fiddling, we discovered how they manipulated and flipped the coordinates to get the yellow track, which was the actual track of the vessel, which turned out to have a questionable license to fish in that area. So that I think also highlights the importance of knowing the context, and IIS data really is best enjoyed with some other data and some context and background knowledge. And of course, one has to pay attention to the accuracy of the method of analysis. So to show you what can be done with it, especially in the context of conservation and active management, this is the same data as the map I showed you before. And here we can really see the intensity of fishing and the two biggest fishing hotspots, which are unsurprisingly around Europe and China. And with that spread, we can also see areas where we either don't have data. So for example, the Caribbean and Southeast Asia are big data gaps, but also then some real gaps. If you look into the Pacific, around the Pacific Islands, these are the exclusive economic zones that seem to be working pretty well regarding their management. And because we also know the identity and types of the vessels we are observing, we can also see which players are out there. And this was something that personally floored me when we got that result, despite somewhat knowing it, but not the dimensions and extent, is the amount of fishing China has ramped up in 2016. So nearly 42% of the fishing effort we observed that year was done by Chinese flagged vessels, which is more than the top 10 next fishing countries combined. So when talking about management and conservation, this is really giving a picture of which players and which stakeholders need to be at the table regarding these conversations. And then also, we were very interested to know what is the pulse of fisheries, what makes fisheries tick as they do. And this really came out of the thought that humans are natural predators, and like other predators, we're driven by natural cycles, for example. But we had a long, good look and looked again and again, and we could not really find much. So instead, we came up with this, which is a bit of an unusual depiction. So to walk you through, on the y-axis, you see latitude, and on the x-axis, you see time. So you basically need to imagine to look down on latitude by time. And depicted from yellow, light greenish to dark blue is fishing intensity. And when we plotted this, we at first thought we had some artifacts in the data, but they were too regular. So especially the big gap here in the middle of each year, denoted with Roman number 1, which upon closer inspection turned out to be the Chinese fishing moratorium. So every year in the middle of the northern summer, China calls back its boats, and because the fleets are so massive, this shows up in the global data. Then even looking further north, we also saw some patterns, mainly around the end of the year. And this indeed turned out to be Christmas and New Year's, because fishermen like to be home with their families during that time. So fishing effort is less during that time. And if you squint a bit, you can see a fine pattern like around the same latitude, which turned out to be the weekends. So similar thing, fishermen are like to be home with their families for the weekends. So the only pattern we really found for that correlates to natural cycles is denoted by number 4 here, which is the Indian Ocean tuna fleet moving up and down with monsoon times. So this really highlights that the technology and the rapid evolution of technology, of course, has removed us a step from these natural cycles. We are really cultural predators now. So the influence of culture is also nicely illustrated if you look at the actual tracks. And I hope this video plays. So this here, what you can see, the little lights are fishing efforts. So this is one of the first versions of the Global Fishing Watch map. And showing around the Azores for some vessels. So you see a time slider. This is approaching Christmas. Vessels are going back to Spain and Portugal. And then in the new year, they are coming back. So this just highlights basically on the water what you could see in the graph before that. And we can also use this data to assess marine protected areas. So the first example I would like to use here is coming from the Phoenix Islands protected area in Kiribati in the Pacific. which area was closed at the beginning of 2015. So it had been a protected area before, but had significant fishing effort inside, which was licensed. But then it was turned into a no-take area. And this is what we saw 3 months before and 3 months afterwards. So really, this gives us a big scale observation and window into seeing the movements of these vessels and also where they went after that. And as often said, the vessels are being displaced. We could not find that following some of these vessels, they dispersed pretty widely following the closure of this protected area. And then we can also learn more about how vessels and how fisheries are really reacting to marine protection. And this is a study we did around the Galapagos Marine Reserve, which is the green avocado-shaped form in the little map. And each red dot you can see is a purse seiner set for tuna fisheries. And the grid denotes the study area. And by looking at where these sets were, we found that about 4 times as many sets were set within 20 kilometers from the boundary of the Galapagos Marine Reserve compared to the whole study area. And that is mainly in what we call the hotspot to the southwest of the reserve, which is also a really good fishing ground, of course. And this kind of data really comes in handy. I don't know if you have heard about plans to expand the Galapagos Marine Reserve and currently figure into design and zoning plans for something like this. And then also an important thing to highlight is that, and I guess that also loops back to talking about not only quantity of protected areas, but also quality, that this type of data, because it affords us a big picture look, enables us to assess management. This is a study we published in 2018, looking at fisheries in European waters, shallower than 800 meters, I'd like to note, and the connection to the network of marine protected areas in Europe. So this is over 700 protected areas we included in the study. And we found that on average trawling effort in these waters is 1.4 times higher inside marine protected areas than outside. I would like to note that this is not illegal fishing. It's simply a result of the European Union's policy to manage fisheries separately under a separate piece of legislation compared to nature conservation. So we compared this to abundance of Europe's most vulnerable groups of species, which are elasmobranchs. So included, I think it was 20 different species, and analyzed data from research catches by Hall and found that these elasmobranchs were on average 2.3 times more common outside the protected areas than inside, especially the most endangered ones up to 5 times more common outside. So with regards to managing protected areas, I'd like to note that none of these protected areas has been specifically designed for elasmobranchs, but they represent one of the most vulnerable groups. So the current management seems to be failing this group. So to change track a bit from the future to the present to what we can done and look ahead, I'd like to stress again that we do have the understanding and data necessary for robust protection and management of biodiversity. We just need to make it happen. We need to especially move from reactive approaches to proactive approaches. However, management indeed is often hampered by inadequate information to support decision making. So decisions are being made, but they're often not using the best data available because this data often is inaccessible or not used in the right kind of ways. And this failure really to get the data from those who produce it to those who use it and then implement it leads to lost opportunities to inform management decisions. So I'm very pleased to be talking about a new project I'm working on in collaboration with Global Fishing Watch, which is a new tool called Global Fishing Watch Marine Reserves that we're going to launch for first looks in May this year. And what it is, it's a free online tool that is a data fusion analysis and monitoring platform. So similar to Global Fishing Watch, which will be closely coupled to, it's a tool that aims to specifically support marine conservation planning, management, and monitoring. So we're targeting as target audience marine managers, spatial planners, and of course scientists working alongside these topics. There's a public dashboard that everybody can access for free to help promote the sites we're working with to raise awareness and educate, of course. And then there's a range of, or there's the possibility to create private collaboration workspaces that can be shared with teams to really enable dedicated work using the data sets included in the platform, but also upload, for example, data that cannot be shared publicly, but within the wider team, to foster collaborations across countries and institutes and organizations, and provide standardized data for these approaches. So data layers included really can be divided into the three big buckets, and some tools are already out there that are approaching this, but we're taking this a step further. So of course we're providing the oceanographic data such as sea surface temperature, bathymetry, salinity, and currents. And any one of you who has ever worked with this type of data might relate to how overwhelming it can be to find the right data set, to access it, and also to just like really unpack it from file formats I personally had never heard of before starting to work with this type of data. The next step then is to really link the physical properties to the biological. So we're bringing in, of course, chlorophyll like primary productivity data, but then also go a step further in collaboration with the MICO project to bring in data on migratory patterns and migratory connectivity. And then in collaboration with actually the very own Gabriel Regondo here on habitat suitability, and also, of course, on data on coastal and deep sea ecosystems. And then lastly, and this is the real step where we see the value of this tool, link this to human use data. So the obvious, of course, is the fishing AIS data. But then we have a whole big data set on non-fishing vessels. So any shipping and its impacts, and data sets on vessels that are not appearing on AIS. So the VMS that gets shared with Global Fishing Watch, dark targets that do not have any transponder. And then, of course, the impacts these vessels have. So currently in collaboration with JASCO, we are producing the first global underwater noise map. And this will include, of course, specific information on things such as seismic testing for resource extraction. And going beyond the noise, other data sets on human uses such as mining, tourism, and anything else that is of interest. And these data really, of course, feed hopefully into the work marine managers do and scientists do. And to further certain types of work, we have 4 big projects that are science that are supporting or generating data for this for Global Fishing Watch Marine Reserve. And climate change is one of the biggest ones, of course. So we're currently working to track and forecast climate change in these data sets to see their induced impacts and to help build resilience, for example, by better understanding how climate change data can be incorporated into MPA management. I mentioned the underwater noise, that we map the anthropogenic underwater noise, especially for management around noise sensitive species. And I think this is something that is very familiar for anyone on the West Coast regarding the work around, for example, the orcas. And then, as I just mentioned, in close collaboration with MICO and then with Gabriel and William Chung's group at UBC, we're looking at migratory species and habitat suitability and how this links to the protected area networks and the spread of networks across biodiversity gradients, for example, and how it can be figured into management, even looking into how these kind of data sets can be made dynamic to interact with this dynamic map, and then even with respect to forecasting this into the future under climate change. And lastly, to make the human use really more tangible for planners and managers, we're developing a human use index that is dynamic. So a lot of you will probably be familiar with the work of Halpern et al. Regarding the cumulative human impact maps. So along these lines, but under using really a dynamic, up-to-date data that enables managers to monitor and adjust and react to human stressors in their areas of interest. So just to give you a quick look into what the tool looks like, and I would have loved to do a live demo, but I don't trust the internet enough for that. So I'm showing you some screenshots. So we currently work at 5 pilot sites that we're expanding this year, which is Galapagos, Guyana, Tristan da Cunha, Ascension, and Palau. And this is an example here of the workspaces that can be created, that can be also shared within teams. And users are able to either click predefined areas or upload or draw areas of interest. And within these, then data sets can be either uploaded or selected for use. And I've shown here fishing effort in blue and sea surface temperature for the Galapagos Marine Reserve, and depicted in pink, and the exclusive economic zone in greenish. And you can see at the bottom, there's a, I don't know if you can see my mouse, at the bottom, there's a time slider. So the user has the option to really select the time of interest, select the area of interest. And then when you mouse over, the values will be shown and graphs will be created to give you a quick overview of the development of the respective parameters in the area of interest. And that can then be connected to data that can be uploaded into your private workspaces. Here, for example, that might be sensitive data such as whale shark tracks, as shown here in orange, originating out of the north of the Galapagos Marine Reserve, and then be used to look at the area use of these species, for example, here shown in blue, compared to fishing effort over time. And these data sets then also can be downloaded because they were standardized to the same resolution, and then ideally be used offline in further analysis. To give another example for Ascension Island, so this is the marine protected area in Ascension, and Ascension being this tiny dot at the middle of the circle. And the other circles around it depict locations of seamounts, and in green, the habitat suitability index for blue sharks that Gabriel and his colleagues have developed, and in pink, the fishing effort around Ascension Island. So again, this can be used for very direct management questions to monitor not only over time, of course, how the habitat suitability might change, but also how the human use and stresses in this potentially suitable habitat are developing over time. And to conclude, I'd like to walk you through 2 examples we are currently working on. So one is the impacts of underwater noise on marine megafauna. This is a collaboration with Guyana, where a new oil field has been developed over the last years. It's a bit hard to see in the map. It's depicted in orange right here. And in this lighter yellow is the fishing effort for the wider Caribbean, and in purple, the general vessel traffic as seen from AIS. And Guyana and Trinidad and surrounding countries have noticed a very recent increase of cetacean strandings, especially sperm whales, which had not been recorded before to that extent. So they're really interested to see how increased vessel traffic and underwater noise might contribute to that. And just to give you an impression, this is a very hectic map, hectic because this is seismic testing vessels that have been active in the area between 2014 and 2018. And all these back and forth very regular patterns are seismic testing patterns. And this, of course, makes for an incredibly noisy environment while these testings are going on. And similarly, along these lines, this is partly fake data, I'd like to mention, to test this type of analysis. We are aiming to create maps and images and knowledge around the soundscape species might be experiencing over their suitable habitat range. In this case, for the Eastern Tropical Pacific, for sperm whales, underwater noise versus their habitat suitability index. And lastly, to loop it back to the climate change topic and the marine spatial planning, this is Ascension Island again, and their managers, their managing team is very interested in better understanding the role Ascension Island has for ocean basin-wide management of species of interest, mainly also migratory species, of course, and the role the marine protected area plays in that. So in red, you can see the habitat suitability for big-eye tuna outlined, and then the sea surface temperature anomalies for the year 2019 moving through this. So really highlighting that in order to make the best use of this data, we need to have ideally need to be having dynamic data, and to answer questions on how climate change will impact large marine protected areas such as Ascension, and how these impacts can be mitigated or encountered, especially through design, and then of course the management going ahead. And with that, I'd like to conclude that we're in this age of rapid change, but this rapid change really requires and stimulates a new flexible way of thinking, because the biggest challenges are rolling right our way, but we are not facing that completely unprepared. We have a range of new tools and dynamic approaches that are becoming increasingly important, and the good thing is that we have an unprecedented data revolution that provides us with the opportunity to meet these straight on. So for this, it is really necessary that we are aware of this, and we are really keen to face this, and also recognize that for this we need to bridge the tech science and policy gaps that we currently have, and then really start to implement and work with the data we have, create new data as we need it the most, and then move ahead together. I thank you very much for your attention. Especially thank you for inviting me to talk here. Of course, also to all the collaborators. And I'm happy and looking forward to answering questions. If there's anything you'd like to know, please don't be shy to send me an email or connect with me on Twitter. Thank you so much.
Thank you, Kristina. We open now the question and answer part of this talk. I'm going to start with a simple one. With all the data, developing a tool to create potential new areas for MPAs in the world.
That's the ultimate goal. The name, the marine reserves, is a bit misleading right now. We really aim at marine spatial planning and to support that. And of course, there's a big ongoing debate on where marine protected areas should be sited, what range or what spread one wants across, for example, different gradients of human use, or I've shown the examples of different climate scenarios. So we really aim to provide global data on this end, and a broad understanding, so this can be work on this can be facilitated and empowered. And as we've seen with other, arguably with other objectives in mind, we have not really gotten, especially where the climate change factor is considered, a good spread of where areas are located yet. So yeah, we really hope this kind of work can get more clarity and more data and add to this discussion.
Thank you.
Thanks, Kristina. Whilst we let other people think of some questions, I'll jump in and I'll ask one as well. I was just curious because I really liked how you introduced the work that you do, from going from a reactive to a sort of more proactive approach and also linking the science to the actual action. So I was just curious, and this is perhaps more of like a personal reflection, how the action environment, so let's say policymakers or corporate players, have responded to some of your work. So, you know, some positive interactions that you've had, or some surprising reactions that you have, and how those have been communicated to you in that environment.
So specifically for policymakers,
you can pick policymakers, or you can pick corporate actors, whichever one you want to highlight.
I think generally we've gotten very positive responses to an approach like that, because most people, especially people who have worked with this type of data, can really relate to the amount of data that is there, but to the difficulties, if I phrase it like that, to really use it and access it, and how long and how much knowledge it really takes. And this is even in areas where there's a lot of access and a lot of training and capability available. So really aim to also empower nations that might not have this kind of training and access. And I think most people have really had, really see the type of use this would have to answer the questions they are struggling with. And we've brought together, I think it was 29 different marine spatial planners and managers, from government down to NGOs, and actually, or not down, to NGOs and managers of marine reserves. And when we talked about what goals and objectives they had, we were surprised how much they really overlapped and centered around the use of certain types of data sets. For example, the human use, really to understand what are the stresses and pressures out there, to what types of data and types of science they needed. So I'm very positive going forward, and I'm looking forward when this is launched and we start to work with more partners to, of course, learn more, because we develop this also really ongoing with the science and the work in the pilot sites, to really learn what they need and then incorporate that accordingly.
We have a question from Deng Palomares. So Deng, if you can unmute and put your camera on. And unmute.
Okay, so hi, Kristina. I was a little bit confused. I sort of like missed the slides on the biomass models, and I was a little bit confused about what kind of data went into estimating those models. So can you specify them again, please?
So I would like to say I was not involved in that type of work. I know about these modeling projects. Most of them are taking different types of models coming out of the CMIP project into account, modeling on or combining a range of different models to find the best fit of these models. And specifically for the NAFO model that I showed, the types of fisheries catch and landings data was included for that, and then forecasted under these different scenarios using this ensemble of models. But for further information, I would direct you to those publications.
Okay, so if I understood correctly, they were models from assessments, correct? Like predictions of biomass using references, say population references.
That's how I remember it from those publications. Okay. Yes.
Thank you.
And Leonid Petrov, I will go to you next, but I just wanted to quickly, Kristina, Salome brought up that it would be great if you could share the link to the Galapagos report, please. So we can figure out a way to do that, but just there was interest in the Galapagos report that you mentioned.
The publication itself?
Maybe I'll let her follow this up with you directly, sorry. So Leonid, if you wanted to.
Good afternoon. Thank you very much, Kristina, for your interesting report. I would like to ask about noise pollution and its influence on the marine species. I am right that the most vulnerable species are the most the most big in their size species, such as big mammals, as you mentioned, sperm, mm, sorry, cachalots, sharks, and other big species. I'm sorry. Thank you.
Yes, they are certainly the obvious focus because of course the strandings create a lot of attention, and they are charismatic megafauna really, so people are concerned, and they can be impacted by different types of noise, even if it's like, for example, louder than usual background noise that can impact their echolocations, their hunting, even result in strandings, to, of course, very direct impacts of high impact noises, such as the seismic testing, which exceeds levels. I've read a comparison of for humans standing next to a starting airplane, that really causes brain injuries, ruptured eardrums, bleedings, not only for really cetaceans, but also, as studies have found out, to fish, of course, down to the level of really harming plankton. So we're really at the beginning, and I'm not an expert in ocean acoustics, but it's incredibly complex topic, and involves incredibly complex modeling. But really, if we're talking about better protection and human impacts, this is certainly a dimension that has been largely, to my opinion, largely neglected so far in conservation. And I'm really excited to see this as more and more of a focus of campaigns and research, really.
Thank you.
Thank you. I think the next question is from Andrea. So Andrea, if you can unmute and ask your question.
Hi, Kristina. That was a really interesting talk, enjoyed that. Before I ask my actual question, on the topic of noise pollution, I imagine that to be really hard to quantify since noise travels so far. Are there even areas in their ocean that are silent, or is it just a noise spectrum across the oceans?
It's, as I say, I'm not an expert on that, but having seen how this is being modeled, I don't think any area really is ever quiet, because there's maybe the deep sea, I don't know, but there's a lot of like ambient noise and natural noises that fish make, that different types of processes make. So the really comprehensive models really take into account things like, of course, water movements, currents, density, temperature, waves, wind, even rain on water surfaces makes noise. So, and on top of all this ambient noise, of course, ships coming through, or any types of testing and equipment use underwater makes even more noise. So it's an incredibly complex field, and I feel we're really trying to contribute some broad knowledge that we hope people then take into their areas of expertise and run with, and deepen on these kind of things.
Okay, thanks. And then my actual question was, if aquaculture was taken into account as a human stressor, especially in those last models of the global fishing watch that you were showing?
Yes, very good question. Certainly, we have a big folder called Aquaculture, but so far with the pilot sites we have, it has not come up. We expect this to change as we take on new pilot sites. So with that, we'll be doing some digging into how available data is on aquaculture sites. We're thinking about trying to use a proxy, which are the vessels going to aquaculture sites, to use this as a location, even if we don't have data on where these actual sites are, to at least show that there's human activity in these areas. But it's certainly going to be one of the areas of discussion.
Cool.
Thank you.
The next question is from William Chung. So William, if you can unmute and put your video.
Hello, hi, Kristina. It's great to hear your talk. Very, very excellent talk. Thanks very much. I have questions. So you have done all these amazing scientific studies, and a lot of it are very policy relevant. And so I just want to ask whether you can share your experience with us of what strategies that you think work best in making sure that all these amazing scientific work can help with supporting policy discussions, and that there is, for example, policymakers would understand the science and then be and also used in those discussion forum. Thanks very much.
Excellent question, right on the money with that. This is something we really also want to, or actually that mainly motivated the creation and the work on this tool, is to facilitate the access to the outputs of this of the scientific work. Because I think it's, as sad as it is understandable that managers who have no background in marine science necessarily, or even policymakers, are slightly overwhelmed, I would say, when they get presented with model outputs or the complexity of it, and then of course the uncertainties that are connected. And we really try to make this more approachable by having this tool that is very direct in its use and presents what a lot of the managers and often policymakers need, which is a broader overview first. And then really when that kind of stage is set, to be able to be reaching out, and we will have a separate page where of course the data sets and the accompanying publications are linked, but also aim at providing this as a platform for understandable science communication. And I think this is really the key, that for example, the habitat suitability index that Gabriel is working on is a great thing, but it's like when I talk to my grandma, for example, about it, it doesn't mean anything to her. So but when I say like this is really used by managers to understand how species move in and out potentially in the future, and how they need to look out for them, this of course makes a whole different sense. And really the application, this is why we so focused on the application that I see transports the science here, and we hope we can develop with partners like yourself a strong platform to really bring out that science and have it applied, and then through these applications tell the stories of that.
Thanks very much, Kristina.
Yeah.
Thank you, Kristina. There is a suggestion from Emily Toucaille from France, who just asked quickly, do you know the European portal for marine data called EMODNet and CMEMS?
I do, yes. The Europeans are really exemplary regarding data transparency and data sharing. And of course, NOAA and the DFO to a certain degree are also doing good jobs at that. So we're really trying to, we're really standing on the shoulders of giants in this aspect, and are trying to use these types of data sharing portals to target, to bring this to our target audiences in the realm of marine spatial planning. So good to highlight those, definitely.